So, Michelle Holko, okay, the credo of Soft and Savage is that there are those who are faced with challenges and there are those who seek challenges. Soft and Savage is the universe where both excel. And after reading the report that you sent me on the National Security Commission for Emergency Biotechnology, you, we are clearly uh, we are clearly faced with a monumental challenge. So, Michelle Hogo, welcome to Soft and Savage.
Thank you so much, Louise. I'm so glad to be here. Before we get started, I just wanted to share with everybody that, I'm speaking on behalf of myself and not any of the organizations I've previously represented or worked for, and very excited to talk with you and unpack this National Security Commission on Emerging Biotechnology report.
Fantastic. Thank you. Okay. So when I think about AI, and it's not that I'm a genius, I'm a bit of a dilettante around that, but when I think of AI, I think of ChatGPT, and I think about the fact that people are talking about the fact that these aren't machines, that they are sentient beings, and that they may get to the point where they're making their own decisions about the imminent annihilation of mankind and all of that. But I had never looked at it from the perspective of the intersection of biotechnology and AI. And that's what this paper is all about. So can you walk?
Yeah, well, you're definitely not alone in that. I think that, a lot of the study of biology has been going on for hundreds of years. And, really the study of biology is the study of life. So when we figure out, kind of what's going on from a biological perspective, we're really discovering what does it mean to be alive and how do we understand, what that is. But we're reaching a tipping point where we're moving from discovery, simply discovery of biology, to actual design using biology. And this is where, AI has been one of the very instrumental technologies that is leading to this tipping point moment where now we're at this kind of precipice where there's this potential to kind of own the understanding of how to leverage and design biology and biomanufacturing at scale in order to create whatever it is that you need to know to make, to support life. And that can be, things that are life-saving medicines. Actually, we've made a lot of progress early in the healthcare field, but this is cross-cutting all of the various fields. So thinking about food and agriculture, thinking about energy sources, thinking about manufacturing of materials, information storage, and national security and defense. So it's really a cross-cutting moment where we have this opportunity to either lead or cede that leadership to another global power.
Yeah, and I think that you mentioned, and I don't want to paraphrase, but I think that you mentioned that this should really be a moonshot kind of an effort because if we lose to the Chinese, who are our biggest competitors, that the potential for our imminent annihilation in so many of these different areas that you just described would be assured.
Yeah, that's a really great point. And this commission report is framed as a moonshot. And the moonshot obviously refers to the Apollo mission of going to the moon for the first time. But I would argue that we've already seen a moonshot in biology, and that is around next generation sequencing. So right around the time when I was starting my PhD in 1999 and 2000 is when the first papers about sequencing the human genome were published. And this was a whole of government effort. So you had, the whole of the US federal government also working with allies. There was also a private sector effort to sequence the human genome. And it was, $1 billion effort to sequence one human genome. And now, since then, in 25 years, we've seen tremendous innovation because of that foundational moonshot investment by the US federal government. We've seen the ability of the private sector to continue to innovate of course, there's been additional federal dollars that have been put towards streamlining and making next-gen sequencing faster in a lot of different ways. But now to where you can sequence a genome in about an hour for, less than $1,000. And so that, I think, is a tremendous example of the way in which technology plays a critical and important role in science, and then translating those into actual industries that we're able to use for commercial reasons, but also to support life in general.
Well, when you discuss China's efforts in this regard, you say that there is a whole of country effort. And is that still, and this is what you just described in the United States for the Genome Project, but is there still the whole of country effort in the United States with regard to the potentials for biotechnology?
Yeah, so the I would say the main difference between China's whole of country effort and what the US has been doing over the last 25 years is that in the US, because we kind of espouse this kind of open source and open innovation ecosystem, it's been less directed and less coordinated. And this is one of the reasons why the commission report, I think, is so important. And if there's nothing else that you take away from this, I think the formation of a national biotechnology coordination office is the most important piece going forward. Because right now, the way things exist in the federal government, there's funding coming out from almost every different department and agency that are being invested into private sector and government and public sector innovation to support biotechnology development, but it's not being coordinated. And so you're leaving potential partnerships on the table. You're leaving the ability to scale those dollars. We're not leveraging as well as we could be the public-private partnerships that also tend to amplify and create commercialization pathways for products. So there are a lot of reasons why I think the National Biotechnology Coordination Office and the formation of such an entity is so critical. On the other hand, for over 2 decades now, China has been quite organized in the way that they've been approaching the problem space. They have stood up, kind of government-run biobanks to bank samples. They have been collecting their own biological data from various types of organisms, including different human genetic ancestry people. They, most notably have been using that information in some cases to suppress genetic minorities within their own populations, which is, of course, not something that the United States would want to do if we were to win, which is why the stakes are so high here, because what we're seeing from the way China is acting is that not only do they have this coordination, which is something that, I think that would be good for the US to have more coordination, but that they are also stealing IP and information from both allied and non-allied nations. They are also trying to, really putting a lot of effort into scaling biomanufacturing. That's another critical missing piece in the puzzle, is that there's a lack of scale. This is one of the reasons it's been so successful in healthcare, is that a lot of times with healthcare, you need just a tiny little bit of amount of something that's been biomanufactured to have a big effect. But when you're manufacturing materials that you're going to use to make homes and other types of uses, you need actually a lot more scale. So that's another effort. And then, the other thing China has been doing is trying to strangle out competitors. And so this is why it's so important for the US to really start to invest in the scaling and in the coordination, so that we are able to maintain access to life-saving medications, to the ways that in the future that we're going to need to use to grow food and be able to heal and nourish ourselves and our populations.
Yeah, and funding is critical to that. I mean, it seems to me that this will boil down to an East-West fight. And 3 or 4 weeks ago, I was flying back from Copenhagen to London, and my seatmate was a man who had been doing stem cell research for the last 20 years. And I said, don't you find it interesting that the United States is cutting the funding in the universities and for research and scientific research? And he said to me, Louise, this is not just happening in the United States. He said it's happening all over Europe as well, because he said that we know that in the next 2 years that we're going to be at war. And so all the money is being taken out of scientific research and invested in defense. So if China has this coordinated effort and this, this whole of country effort, and the West is defunding the science behind this and the research behind this, doesn't that put us at a tremendous disadvantage?
Absolutely. It's a huge risk in this moment. And I would urge legislators in the House and the Senate to maintain funding levels, to do whatever you can to keep funding for our research ecosystem going, in addition to enacting these additional kind of key recommendations around coordination, streamlining regulations. In a lot of cases, when it comes to biotechnology, especially when it comes to biological data, there's a gap there in terms of intellectual property rights and regulation, and so we need to have
Wait,
mechanisms to.
what do you mean by that? What's the story? What's the story with that?
Yeah, so in a lot of cases, biological data are not subject to trade restrictions,
Hmm.
or it's challenging to go through the intellectual property process with biological data unless there's an invention around it. And so one of the challenges is that these data that are being created by U.S. entities and that are funded by U.S. Organizations are not protected in the way that they could and should be. So I'm going to give you an example from earlier in my career. So, after I did my PhD and did a postdoctoral fellowship, I moved into working as a federal employee. First, I was working at NIH at the National Center for Biotechnology Information, which is all of the databases, all of the biological databases. So if you're a scientist and you're receiving federal funding for your research from the US government, you have to make those data available to other scientists. And then these data are housed in these databases at NCBI, at NIH. And so I was working there and noticed that China was replicating the database daily and mentioned to my leadership, China's replicating the database. And they said, oh, yeah, 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 this is something that we're very well aware of. We've created, an API or advanced programmatic interface to make it easier for them to do this, because we're all about open data and sharing. And, we're just essentially like making it easy for people to consume the data however they want to do that. But while China was building up their own databases and not sharing their data, they were also consuming all of the open data that the US was housing. And then take it a step further, about 6 years later, I was working at DARPA in the Defense Advanced Research Projects Agency in the Biological Technologies Office, about a year after it was formed as a contractor. And we had a program that we announced, and then we got a lot of people that applied to the program. And it was a very like multi-species, multi-omic, so lots of different biological data to be collected, including genomic data. And after we did source selection and we had decided who we were going to fund and we made that announcement, one of the groups came to us shortly thereafter and said, "Oh, great news. This company reached out to us. They've offered to do all of the genetic sequence analysis for our program for a third of the cost. Isn't that great? We're going to be able to add all of these other tasks to this project." And, DARPA is part of the Department of Defense. And so obviously our adversaries would be interested in the data that the DoD is interested in, right? And so we, by doing a little bit of sleuthing, realized that this company was tied to BGI, which is Beijing Genomics Institute, which has strong ties to Chinese government. So that all to say that there have been a lot of ways in which this kind of slow background infiltration has been happening, and that while this kind of open science policy that the U.S. has, I think is tremendous, and I don't think we should do away with it. And also, especially for DoD studies, for specific types of sensitive genomic data or other data that may be sensitive around biology, I think we can do a better job of protecting American assets.
So is there a way of protecting that? Are there solutions available?
Yeah, absolutely. There are controlled access databases that have requirements about how to gain access. It's a little bit of a trade-off because as soon as you have that kind of controlled access mechanism, your usership is going to go way down because it takes time and energy to go through those hurdles. But yes, absolutely. And with technology, it gets easier and easier every day to both protect the data and also to stimulate that innovation.
All right, so let's take a look at some of the different things that can go wrong first, and then we'll look at things that can go right. But let's see what can go wrong in terms of defense. What are the kinds of things that the Chinese are using biotechnology and AI for in the defense space?
Yeah, well, in the defense space, China has been very clearly investing in the development of capabilities around super soldiers and being able to integrate technology with humans in such a way that makes them even more powerful than, for example, drone warfare. So that I think is a really kind of a chilling example of why it's important to maintain these capabilities domestically.
So they're building super soldiers. So in other words, they're genetically modifying the soldiers so that they can fight more, don't need to eat as much. I mean, what is it what is it that they're doing?
Yeah, at the moment, and again, some of this information is hard to come by, and in the classified space. But at the moment, what I can say is that it looks a little bit more like it's integrating technology with humans more closely than actual direct genetic modification. But based on the research that we're seeing, it does look like they are doing human performance research, which is aiming towards that kind of super soldier development piece on the genetic front.
Well, And what about nourishment? What about food and agriculture?
Yeah, food is a big one. Food is one that keeps me up at night. I don't know about you, but I think especially from a climate change perspective, we're seeing more and more how it's becoming more and more challenging to get, good, healthy foods that are clean without pesticides. And so, one of the things that China's done that I think is actually really great is they have figured out how to adapt rice to be able to grow in saltier water. So as tides rise, and then your rice paddies end up being a little bit salty, usually that chokes the rice out and they can't grow. But they've been able to, kind of develop strains that are able to withstand that. Ideally, what we would want, though, is for the US to have access to those technologies. And if, for example, if China were to own the intellectual property for all of the adapted kind of agricultural products out there, that they could theoretically use that to starve us out.
Well, and they can use it as a weapon of war because I was reading something in the paper where it was addressing the issue of, let's say, the United States decided to go in to intervene in Taiwan, and the Chinese had a food supply or a medicine that only they could make available to us. And they make it very clear to us that if we go into Taiwan, they are no longer going to be shipping these medicines or these foods to us. And so, what is that going to do to the Vox Populace in the United States? They're going to say, don't go in and don't fight, don't protect them. Don't
That's
protect the Taiwanese people because we'll be starved out or we won't be able to get the medication. So, this is another weapon of war, potential weapon
that's
of
right.
war.
That's right. And to that point, this is where supply chains and biomanufacturing has a tremendous potential to help on the supply chain front. Because, for example, the FDA has a list of essential medicines that, we pretty much need to have access to all the time. And about half of those they're not currently, but they could be manufactured using biomanufacturing rather than traditional methods.
And what about frontline? I read something about how that it's so difficult to get certain things to the front lines now to the soldiers, and that there is a way to provide them with the nourishment that they need, that the medicine that they need, the tools that they need, without having to bring in, without having to bring that in from the outside. They would just be able to manufacture it in place or
Yep,
produce
that's
it in
exactly
place.
it. That's
Yeah.
exactly it. And these are capabilities that, again, have been worked on in the DARPA space since I worked there, and are still being worked on. Is how do you actually do just in time, wherever you are, biomanufacturing of whatever you need, to the point where we're even thinking about how do we do biomanufacturing in space.
Oh my God, yeah. And how close are we to that?
Well, it depends on what you're trying to make. So there was a program called Living Foundries that was trying to manufacture a kind of a wide range of different types of molecules, and I'd say the success is mixed. For some it's easier, for others it's more complicated. One of the challenges comes at component parts. When you have the various component parts that you need to put together to synthesize, how do you do so in such a way that you don't require large influx of those component parts from external sources? So you end up having to link together, like, okay, manufacturing the various component parts and then bringing those together. So it's quite complicated, but I do feel like it's very doable. Just requires a lot of concerted effort around what you need.
Well, and the other thing, when you mentioned that it's very doable, I've heard people speak about AI and say that things that used to take 2 years or 2 months can now be done in 2 hours, 2 weeks, 2 hours, that it's moving that quickly. So is it moving that quickly in the biotech space?
It is. It is. I would say that one of the rate limiting steps in bio AI is the data. Because again, this is where the coordination body is so important in this report. Because the data are fragmented across different databases, different use cases. The different databases have different structure, so it's not the same. So when you think about how ChatGPT was created and all of these LLMs that we're so familiar with now, they had a large, wide range of material to work from on the internet, right? So someone had to make those data all available and readable on the internet, mostly Google. And because that wide range of data, training data existed, people were able to develop these models that could really understand and interact in a way that made sense to people. When it comes to learning how to speak biology, whether that's genomic or proteinish or metabolomic or whatever it is, you really rely on having that same depth of data with the right context around it in order to create those models. And so that's really the rate limiting step. We're seeing some really interesting innovations come out of the private sector. So AlphaFold is a protein structure prediction algorithm that was developed by DeepMind a couple years ago. That's really very similar to the ChatGPT moment, but for protein folding problem. And then Alpha Genome is a new product that just came out. One of the challenges, though, from my perspective of having been a public servant most of my life, is that when algorithms are devised by the private sector, there is a potential for lack of access to the masses. And so that I think is one of the reasons why it's really important that the US federal government stay involved to try and make sure that we're mitigating against any harms that could be caused by that simple fact.
Well, that's what's been going on in the cancer industry for a very long time. We'll have someone who'll be at a university and they know if they find a cure or they find, something that's valuable, they don't want to give it to the university that owns it because they were doing the research there. So they'll leave and they'll go to a private company, to a venture capital company. And then that venture capital will be folded into a bigger firm and a bigger firm, and it takes a very long time to get to market. And it's all about the capital. It's all about the money that can be earned on this rather than the value that it could provide.
Yeah, and not only is it taking a longer time because of that, but the benefit is very skewed, and you have people profiting, exorbitantly, and then the people who actually, their data were used to make the discovery don't see any of that benefit. So it is a huge challenge in the healthcare space.
So do you think that there's going to be a division as a result of this, and that it's going to be the haves are going to have and the have-nots are not going to have? Will it be skewed?
It feels like that's possible. I am inherently an optimist and I believe in the goodness of people. And so I do believe that, a lot of the people, especially in this field in the US that I've worked with, have extraordinarily good intentions. And also, the writing is really on the wall. We have talked a little bit about, for defense, the development of super soldiers, but another elephant in the room that I think a lot of people are talking about, and it would be great if everybody knew about, is that the intersection of bio and AI is also potentially could be used to develop a lot biological weapons. Biological weapons that could be used to harm people directly, biological weapons that could be used to be sprayed on crops and render them, incapable of being used for food. So there's a lot of potential there. And the United States does not, and I hope will not ever have a biological weapons program. But there are countries that do, and China is certainly one of them. And there's good evidence now that the virus that we know of as COVID was being designed as a biological weapon and was leaked from the lab where it was being designed to have specific neurological effects and to impact people's ability to think clearly. And so, again, this is not perfect. It's not like we know that this is for sure true, but there is mounting evidence to suggest that. And so that's a very sobering fact that we are in this age where we really need to be able to protect ourselves against biological weapons that may be created by our adversaries.
And they're so transportable. I mean, this isn't like a
So true.
nuclear bomb. It isn't like a tank. It isn't something that's big and heavy and costly. It's just something that can be sprayed on a blade of wheat.
Or even more so, something that I
Seeds.
could be infected with and then bring along with me and infect other people. And the effects could be short term and you could see them like COVID, or they could be long term and cause cancer in 20 years. So, the detectability is also another problem that I think we
Huh.
need to do a better job of biosurveillance and surveilling not people, but pathogens because that is where biological weapons, I think, are most likely to go.
Is that possible?
Yeah, we've thankfully, because one of the good things about a forcing function is that it forces you to do things differently and innovate. And COVID really did bring forward wastewater testing as a very useful way to do biosurveillance. And some of that capability has remained, especially at points of entry, airports and airplanes. There is still a robust wastewater testing program happening there. I think there could be more. I think it would be great if we had, more ubiquitous wastewater testing. Of course, air testing would also be great. That technology has not been proven out yet at scale in the way that it could be, but I think, we could get there if we really put some effort into it.
But I mean, you could just send a team of people over that are infected, and how would you ever trace that, especially if it's something that's latent?
Exactly. Exactly.
You're not supposed to say exactly. You're supposed to provide me with the solution for this and tell me that we're working on it. Yeah.
Yeah, well, we do need to work on it. And I think that's one of the reasons why this is such an important topic.
Yeah, absolutely. And then as an outlier, I was reading about rare earth metals that you're using biotechnology to clean rare earth metals.
Yeah, so rare earth metals are, they're used in our critical technologies like chips, semiconductors, and they literally make our information flow and allow for that kind of global connectivity that we enjoy in our modern world. But there are a lot of sources of critical minerals that are contaminated by forever chemicals, PFAS, and others. And so one of the utilities for biotechnology is to develop capabilities to clean those sources of rare minerals so that they can actually be used and mined. Whereas right now, they're kind of understood to be contaminated and not usable.
And is it the same technology that would be used to clean a brown field?
Similar, yeah, it's a similar approach.
Interesting.
Yeah.
So if you could design the perfect scenario, what would it be in this space?
Yeah, well, if I were designing the perfect scenario, I would absolutely advocate for pushing forward the recommendations in the report, which are create the National Biotechnology Coordination Office, mobilize the private sector. And that looks like a lot of different things around regulation, around capital, around partnerships. It also looks like, thinking about how is the U.S. Department of Defense going to create a defensive capability around biological weapons? And how is the Department of Defense going to make sure that we're not feeding the beast, that we're not actually putting investments out that are actually stimulating China's ecosystem around biotechnology and bioweapons manufacturing? The other big one is, workforce. We are going to need people who are able to do this type of biomanufacturing work at all levels. So, I think one of the challenges with biology is that people have thought that they need to get a PhD to even be relevant in the field. And when it comes to biomanufacturing, that's just not the case. And then finally, partnering with our allies and out innovating our competitors. And without innovating our competitors, thinking about what resources do we have that we're not using to the maximal benefit. And number one for me there is data. So how do we actually develop a data infrastructure around biological data that's not just one sector, that's not just one use case, that's not multiple different databases that don't interoperate and don't talk to each other, but how do we build this sustainable infrastructure that's needed to actually enable both discovery and then development of products at scale?
And how likely do you think that is?
Well, you are asking for me to read the tea leaves in this very highly uncertain time. And unfortunately, I just don't have a crystal ball. I could ask my magic 8 ball, but that would be probably not so useful. I think that if the United States takes action this year, I think we have a shot. I will also note, though, that when the commission started its work about a year and a half ago, it was clear that the US was pretty much in the lead when it came to biotechnology and biomanufacturing. And in just a year and a half, it has become clear that China has taken the lead. And so we are, I would say, still in the game, very close neck and neck. But if we do not act this year, I worry that we will lose more ground.
So just to end with a positive spin, can we do a lightning round about the different areas that biotechnology touches and see what the best possible case and what the dream scenario would be with regard to that? So in terms of healing, what would be the best potential?
Yeah, well, in terms of healing, there is so much potential around using an individual's genomics to let us guide therapies that are more precise for that individual. And especially when it comes to cancer, every cancer is unique. Even if I have two different cancers, they're going to be unique. And we are so close to being able to really unlock those puzzles and to understand how best to treat people on an individual level for long-term benefit. And so that's an incredibly exciting area.
And how about nourishment? How about agriculture?
Well, being able to grow foods that are resistant to pests. So, being able to reduce the amount of pesticides and the toxic burden in our food system, being able to grow food that are adapting to the changing climate and changing growth systems.
And manufacturing?
Manufacturing, certainly being able to remove contaminants from critical mineral supplies that we have access to, being able to, as we talked about, on demand, manufacture things that you need, where you need them, when you need them.
And the military, finally.
Yeah, finally, with the military, also being able to manufacture what you need when you're out in the field with a much lower footprint, being able to reshore munitions development, and being able to defend against biological weapons.
Okay. And the one thing that I didn't ask you, which I should have asked you at the beginning, is what is your background? How do you come to all of this?
So I trained as a genetics and PhD, and I did a biology undergraduate, and actually thought I wanted to go to vet school and do veterinary medicine. So went to vet school for about a year and realized I was in the wrong place. And so pivoted to a grad program in genetics. I actually did cancer research. And then for that, again, because that was at the time when the Genome Project was coming to light, I became fascinated with the amount of data that we were able to get at the genomic scale. And so for my postdoc, I learned how to do computer programming and to start to, be able to work with the data programmatically. And so that's what took me to NCBI at NIH and working with the data in the databases. I was there for about 5 years, and then I moved over to Booz Allen Hamilton, which is how I consulted with DARPA for about 5 years, which was an incredibly exciting time. Not only was I learning all about, biological defense, but I was also learning about, high risk, high reward research and that entire ecosystem of really being able to innovate at scale and do emerging technology. So that was a really exciting time. We were funding the mRNA-based vaccine development. We were looking at data from wearables to understand physiological signals before you even have any symptoms. And then since then, I have worked as a White House Presidential Innovation Fellow, which was a really fun role. And that's where I was when COVID hit. So I got to see a lot of interesting things, was plugged into Operation Warp Speed from a security perspective, and worked with the Pentagon on chemical and biological defense matters. And then since then, I've been, doing some various things. I continue to really push forward this biodata ecosystem space. Right now, I work with the very first company that I ever worked for that got me a space at NCBI, which is where I was had my first federal job,
What's
uh,
NCBI?
National Center for Biotechnology Information. So these are all the databases.
Oh, yeah.
So I'm actually helping to, think about what is the future of biological databases and the data ecosystem, and how do we actually chart through this AI moment when it comes to biological data.
Well, thank God that there is someone of your caliber and your expertise and your kindness and your commitment to the human spirit and humankind that's working on this, because it's a very dangerous area. It's potentially, you know,
It is. It
the
is. It is.
eradication of mankind.
It is chilling. I mean, I think one of the things that is most chilling to me is that because biology holds the secrets of life, the holder of the secrets of biology has the power to decide what life is worth saving and what life is not worth saving. And I think that is a very sobering reason why I think this is so important. And I'm so grateful to have worked with the commission. I worked with them for about a year and a half, very part-time, but was very happy to play a small part in putting this tremendous report together.
Michelle Holko, thank you so very much.
Thank you, Louise.
It was a pleasure.